Hey, what's going on, everybody? It's Mike from Dungeons and Diving. We're back with our part 2 for our DLL Injection series. And basically where we left off in part 1 was we had a DLL that would be called from a main application, and as soon as it attached to the new application, it would print out a cout statement with hello world from DLL land, and then additionally it would call this funny function that we generated. Because the way C works is you have to declare the function before you can use it, or up at the top you can put a function prototype. We do need to move this to the top. It's such a small function, we're not going to worry about function prototypes here, we're just going to move it. And the reason being is because as we expand this project, we need to actually utilize this process attach in the UL reason for the call. So when our DLL is injected into our target binary, this DLL process attach is going to occur, and we need to use that to actually call our function. So we just move that up top. Next step is I did notice that we didn't need it, but typically you're going to see framework.h is going to be included in these. If you remember from the first video, framework.h literally just called our Windows header file. It's not a big deal. We didn't need it, but it's good practice to have it in there if we already have it developed for us. What we're going to do is we're going to leave our cout statement in here. We will not actually see that. The important thing that we're going to do is we're going to see this system call. Now, because of a limitation we'll get into later, we're not going to launch Notepad, we're just going to launch Calc. And the reason for that is we're going to actually use Notepad as our target binary. Alright, so once we're in here, we are going to have to go and adjust how we're calling our functions. We really don't need any of this other stuff because we're not going to deal with those. At other points you can use them if you want it to be more elegant with your DLL. But we're going to stick with this DLL process attach. And all it's going to do, we're going to remove that cout statement, and we're just going to call funny function. And the reason for that, like I said, as soon as it attaches, we want to run our actual functionality here. Typically, you may have some race conditions, so we're going to avoid doing a whole lot in DLL main. That's why we do a function call, because main will happen, things will set up as they need to, and it gives enough time to actually go ahead and hit where the function is that handles our main code block there. I don't know that we need it here. I'm just going to go ahead and put it anyways. We're going to just return true here. And what that's going to do is as soon as we attach, it's going to call funny function and it's going to return. If you look through down here, it's going to fall through, it's going to break anyways, and then it's going to return anyways. But if we were to do a more expanded functionality here, we could just do it here, we could just do a thread attach, we could set these return statements in the different blocks based on what we're trying to do. So as it stands right now, that is the extent that we actually have to change our DLL. After that, we need to go into our app. Now this is going to have a major change. The way this all worked before is it would actually take the DLL and it would ingest the DLL and run it from within our application. However, that's not what we're going to do. So I'm going to go ahead, remove all of that. There's a few things that we need to change in here on top of that as well. We still need IOStream, we still need tchar, wchar, and Windows. There is a new library that we're going to have to include, and that is TL help 32. And the reason for this is this TL help 32 is going to give us snapshots of what's currently running on the system at the time. The next change we have to do is we have to provide a path to where our DLL is going to live. So I'm going to put a #define, and what that does is this word DLL path. That's just what I'm using here. Anytime our code has DLL path in it, before the compiler actually gets a hold of our code, the preprocessor directive is going to take that and it's actually going to replace it in our code with what follows. So inside of here, you're going to see I just copy and pasted the path of where everything's going to live. And it's going to be YT tutorial underscore DLL.DLL. You know, it's kind of repetitive. Now, there's only one thing you have to keep in mind. So when you're doing this, with Windows, this / character, it's an escape character. So as far as the string is concerned, an escape R is what it looks like. But that's not what I want. I need to escape. That way I actually will generate the / there. So for each of these spots right here, I'm just going to just shove another / into these guys. And this should work. So in our main, we're going to go ahead and still use an std cout statement here. And it is hello world, beginning, attack, sequence now. And again, new line character at the end. You could, since it's using cout, you could use the std : endl, does the same thing. But my understanding is new line just happens a little faster. Not a big deal. Then we got to declare some variables. So I'm going to go ahead and do the variables. I tend to do variables right as soon as I enter the scope. So we need a dword. And this is a PID to know which our identifier is. We need a handle to a process. We need an LP void, LP, and this is a base address. And you can see that it's very useful to put some context in the names that you're giving these guys. I need a size T, and SZ for size, little sterlen, and then this is DLL path. What that's going to do is that's just going to get the length of however long this string is. And it's handy dandy to use the sterlen function instead of hard coding it in there, because if this ever changes, you don't ever have to update this section of the code. And then we need, and one more is going to be an output value. We don't need this, however, if you need to check things, it's handy to do this, and I'll show you later what I'm using these for. And I always try to initialize the basic types as I declare them. All right. So after we begin our program, the first thing we need to do is get a handle. I'm sorry, not a handle, a PID for our binary. Okay. So this is going to be, so we're going to assign it to the PID variable, and then we're going to use find process ID, and this is a function we're going to create. All right, so the next step is to actually go into find process ID, and since it's a longer one, I'm just going to create a function prototype up here. Since PID is a D word, give it the return type of that, and then find process ID there. And so when you're creating a function prototype, if you're not aware, you have to give it the return type, give it a name, and whatever parameters you want. Okay, and then we're going to go ahead and write this function down here. So we could have done this up at top as well. I'm doing it this way just to illustrate both ways, since we did not do the function prototype in the DLL. So dword find process ID. There's no parameters for it. And curly brackets. So we have handle h process snap. And remember I said that TL help 32 library. That's what's going to provide this functionality for us. So that's a handle that we're going to get. Handle for an h process. Process. Oh, forgot a semicolon there. Process entry 32, and this is going to be a type contained in there as well, or defined in there. And then we'll just do PE32, dword, dw priority class, and we'll get into these in just a moment. Okay, so now that we set up our variables, the first thing is we need to generate a snapshot of all of the current running processes on our computer. H process snap equals, and this is the function that we really need from that library up top. And it's create tool help 32 snapshot, and you can see it's right there. Just do autocomplete. All right, we're gonna do th32cs snap process 0. Okay. The next thing we need to do is we do pe32.dw size, and this is a component of this process entry 32 equals size of, and then it's an h process snap, and then we're going to pass the address of pe32. Okay, there we go, semicolon. Now we're going to create an if statement. So if not process 32 first, h process snap and pe32. Then we're going to, I'll explain this in a minute. Close handle, h process snap, and then return false. All caps. There we go. So the next step is we need to, now that we have the list of different processes running on our machine, the next step is to create a loop. And the whole point of the loop is it's going to iterate through the list of processes until it finds the specific process we want. All right, so because we know that we have to loop through it once, instead of doing a while loop, we're going to use a do while loop. Okay, so the first thing that we're going to do is we're going to grab the file and then compare it to the target binary. So we do that by using another if statement. If not WSCMP, so this is doing a wide string compare. WSCMP, yeah, okay, cool. Oh, that's why. pe32.sce, there you go, scexe file, and then target binary. Actually, did we do target binary? Where's our target binary? We didn't create this yet. All right, so we're gonna name this target binary. I didn't get to this yet, but what we're gonna do is we're gonna go ahead and do another pound define. I meant to do that up here. So pound define, and again, it's gonna look for anytime target binary exists, it's just gonna replace it with something else. So we need to do an L. And then I said we were going to use notepad.exe. So what this does, our target binary is notepad.exe. If by any chance you wanted to swap it to a different one, since we're pound defining it here, you can do it there. You can use a variable down below, but it made it super easy to just swap things right here with these pound defines. And it's still squiggly, so I've looked at it. It's WCS, not WSC. All right. MP. There you go. There you go. Okay, so there we go. So it's basically, again, it's just taking it's just a string compare for wide character strings. So it'll get a string from this exe file name and then our target binary name. All right. So if it's not that, then we want to return pe32.th32 process ID. Bam. There we go. Missing a close parentheses. Okay, and then the next step is to continue the while loop. While process 32 next, h process snap and p32. Okay. So again, the purpose of this loop is it'll keep looping until we find where the process ID and the target binary match up. And then it's going to continue processing these as long as there's still more PIDs to go through. All right, so once this is done, we are going to return 0. So the point of this entire bit of code is just to find the process ID. The next thing we need to do is we need to get a handle on that process now that we know which process it is. Okay, so h process, it's a handle to our process, and then we're going to use the open process function. We need to provide it all access, and you can see we've got access whether we want security permissions to be inherited, and then we need to pass it the ID. So we're going to go ahead and process all access true, and then we need to pass the PID. There we go. Okay, so this is going to get us the handle to the process. Once we have the handle to the process, we can move along and actually start tinkering with it. So the first step that we need to do is we need to allocate memory inside of that process. And you could do a couple different ways. You can actually shove your entire DLL in there and run it there. However, that takes quite a bit of setup that's beyond the basics. The more simple way to do it is to just give it the path of the DLL. And we will just tell that process to open the DLL up and load rather than manually trying to load it, simply because it's much easier. Now that we have our handle, we're going to create that memory as I spoke about. Memory in target process. I guess a better word is allocate memory. But what that's going to do is once we use this function, we're going to get a base address. So we have a pointer to base address equals virtual alloc ex. All right. So virtual alloc ex takes a bunch of parameters. It needs a handle to the process. It needs address. It needs a size. It needs permissions, and it needs some read-write capabilities and stuff, and whether it can execute. So just to make it super simple, h process is the handle to the process that we are looking at. Just use null for the second one. sz for the size is the strlen based on this path. The next is we need to do some memory permissions. So mem commit, and then we're gonna pipe for an or, and then mem reserve. Okay, and then the last parameter we need to provide it is page execute, and then read and write. So we're gonna go ahead and put that in there. All right, I know it's a little bit crazy for people who aren't familiar with it. Just trust me, it's gonna work. So the next thing we need to do is we need to write this DLL path to the target binary. All right, so this memory that we're gonna write it to is based on the base address when we allocated the memory there. All right, so it is going to be, it's going to return an integer. So this is where I mentioned that output val before. We're not actually going to use it. When I was working through this, I used it for testing. Again, I output it to the screen. You can do that if you want to, but you don't really have to. All right, so in order to write to the memory, it's going to be write process memory. And again, this is going to take some parameters. It needs to know which process. It needs to know which address. It's going to need to a buffer containing what we want to write, and then it also needs the size. There's also a pointer that you can point to where it says number of bytes written. We don't care about how many bytes were written. We know it's going to write our buffer. But if you needed to track that, you can do that too. So let's go ahead and add these in there. It's h process lp base address DLL path. And remember, like I said, since this is pound defined, before it's compiled, this whole string is going to actually replace this DLL path right there. DLL path, it needs the size, and again, because I said we don't care about getting any data back about how many bytes were actually written, we're just going to use null for the last one. Now that our DLL's path is written into the binary's memory, we need to do some fun business here. So the next step is going to be 2 parts, and the point of it is we need to use a function called LoadLibraryA to load our DLL in memory over on our target process. The problem is we can't just call LoadLibraryA. What we need to do is we're going to create a thread that does that for us. But before we can create that thread, we need to know where LoadLibrary exists. And in order to do that, we need to get a handle to kernel32.dll, which is where LoadLibrary lives. So get handle to kernel32.dll. All right. So this is a H module type, and we're just going to call it H module equals get module handle. Again, it's a wide string. So kernel32.dll. All right. So what that's going to do is our system is currently using this. So it's going to reach out into our system and grab a handle to this currently running DLL. It's great. The next thing we need to do is we're going to find the address of LoadLibraryA and where it exists in kernel 32. And we have to do this routinely because of ASLR, where it'll load at a specific base address that changes when you run the program. And the reason it did that is to try and affect how exploits can work. So the first step, like I said, is we need to find where that library currently lives in memory. And what that'll do, the way we do that is get address of LoadLibraryA. It's going to be, we're going to need to put it into a pointer. So long pointer void LP start address equals, this is going to use the function get proc address. Get proc address. And then we're going to we need to give it the handle of H module, which is the handle to kernel 32. So it says, hey, get the address of LoadLibraryA from kernel 32. Okay. Now that we have the address of load library, the next step is to simply create the remote thread that in the target binary. In our case, we're going to create an additional thread in Notepad. Okay, so the way we do that is we need to get a handle to, it's going to be returned by create remote thread. We really don't have to get the return type, but we're going to use it as a simple check to see if injection was successful. And it's not 100% accurate, and I'll explain that when we get to it. Create remote thread in target binary. All right, so handle H thread equals create remote thread. All right, so this takes parameters. It takes the process that we want to inject in. It's going to take some security attributes, but we're gonna just pass it null. It's gonna take a size. We're gonna pass it 0. It's gonna take a thread routine, which is what code is it actually gonna run, and for that we're gonna pass it this start address, which is LoadLibraryA. So it will call the LoadLibraryA function, and then there's parameters that we can give to it right here in LP void parameter. And LoadLibraryA, the parameter that it accepts, is going to be our DLL's path. So LoadLibraryA will load our DLL for us. And then after that, it takes creation flags, which we're not going to set any, It also takes thread ID stuff that we don't care about any of that stuff. So in our create remote thread, again, h process is the first thing that we need to pass it. Again, null there, 0. So our LP start address is an LP void. So we need to actually cast it to an LP thread start routine. So it's LP thread start routine, and it's right there. LP start address. Again, so that's going to be our load library A. Then we need to pass our base address, which is, again, it's just going to take us to the memory. It's the base memory which contains the path of the DLL. 0 and null for those guys that we don't care about at the end. All right, so at this point, our DLL will get the PID, open the process associated with that PID. We'll shove some memory in there. The size of that memory is going to be based on the length of the string. Then we're going to, that virtual add creates it, this write process memory shoves our actual value into that memory. Then we need to get a handle to kernel 32, so that way we can get the address of load library contained inside of that DLL. And then we're going to go ahead and create the remote thread by passing it the process to create the thread in. The LP start address means the start routine is going to be load library A, and then it's going to use the address of this buffer that we shoved in our path to the DLL. The last step, and like I said, I'm going to use this to do a little bit of checking. I've seen that you can actually have a injection successful response with it not being actually successful. So if create remote thread fails, it will give you a value of 0. So h thread, so if h thread, meaning anything other than 0, we're going to, I'm going to swap here. I'm not going to use cout, just to illustrate that for your straight C programmers, you can still use printf. And this will work just fine. All right, and then else printf. Okay, so this is our complete setup. Next step is I'm going to build the solution. Hopefully everything works just fine. 2 succeeded, 0 failed. We're golden. So I'm going to go ahead and pull up Notepad. You can see that it's running. And then I'm going to run this. And if everything works, we will see calc.exe pop up. Oh, hey, look, injection failed. Now, why is that? Okay, so I figured out what the error was. I had a typo in the code in the bottom. I'll walk you through really quick. So I've restarted Notepad. Again, this is going to fail, and you can see that this injection failed. All right, so going through the bottom here, I realized that this h process L, I'm not sure why I had that in there, but that can be deleted. It's not going to hurt anything. We weren't actually using it. The problem is this size of, when I was looking at my notes, I looked at this line and I duplicated up here. So we're going to get rid of that. What it needs is it needs a process entry 32 there. Size of a process 32. There you go. Now, you're going to see that everything up here is still the same. Notepad.exe, none of that's changed. I'll pull up Notepad right here, and then we'll hit play, and you will see that injection was successful. Notepad came to the foreground, and my calculator popped up. So what ended up happening is our app injected all of that code that we wrote into Notepad and then told it to run another thread that is calculator here. So I'll show you something really cool. There's a suite of tools called System Internals. You can grab it for free. Just Google System Internals Suite. And the reason for that, there's a couple applications I want to show you. So I'm going to go ahead and close all those, and I'm going to reopen a fresh copy of Notepad. The reason for that, the reason we need a new copy of it is some issues dealing with LoadLibraryA. Once you call it to load your DLL, most of the time it has issues being able to launch the same DLL again. You can manually do it. There's some stuff you can do to get around it. But again, we're just worried about ensuring that your DLL runs once. The first tool I'm going to show you is Process Monitor. This tool allows us to look at things that happen on the system. There's a whole bunch of features. You can look at registry, file system, network, processes, and profiling events. For us, we care about the file system activity and the process and thread activity. With these tools, we're going to see some file changes, and we're going to see a new thread being created based on our DLL injection. We're going to go into the filter to make things easier so that we don't see everything system-wide. You're going to go down to, I'm going to remove this one. You're going to see, go down to process name, and then notepad.exe, or whatever your target is. Then you click add, apply, and OK. So now what will happen is the only ones that should show are events that are related to Notepad. All right, so I'm going to go ahead and I'm going to click capture. It's going to start capturing. I'm going to click play over in Visual Studio. You can see injection successful, calculator popped up, and I'm going to stop the capture. And the reason for that is you can scroll down here. You can do some stuff, but I want to just search. We'll look for calc. And then you can see that there was a command prompt right here. And then when we did our DLL main, we did a system call of start calc exe. So remember I said it pretty much issued a command prompt, command line option for us. It ran the command.exe is based on system, and then it passed the parameters of start calc.exe to it, which is right here. So that's how you can see the DLL actually functioning within Notepad. That's pretty much all I want to show you in Process Monitor. I'm going to close these windows out because we don't need them anymore. The next one I want to show you is you can look through all the stuff that I have running on my system right now. It's kind of cool. I got tons of stuff. This is a program called Process Explorer. Process Explorer is essentially the Windows Task Manager on steroids. It's really awesome. All right, so I'm going to inject again, but I have a clean version of Notepad open right now. You scroll down here through here. Let's find where Notepad is. Process. No, I don't want to start by process name. There we go. There's Notepad right there. You can see I have a PID of 1696, which our program will find that. What I'm going to do is I'm going to click on properties, and you can go directly into the threads, and we can see all these threads popping up. And you can see there's new ones, and this update's live. All right, so while we're watching this, you can see new ones pop up. You can see the red ones disappearing as they're closing. I'm going to hit go, and then let's watch, see what it does. Inside of here, Notepad. Let's see if I can find it. This gets kind of crazy in here. There's the notepad.exe, bunch of things there. Calc is still open. There's just open calc up here. Oh, it just opened calculator on its own. So the thread, it happened so fast that I honestly didn't see anything happen here, but it opened its own calculator app.exe. So that shows you how you can actually see what happens on your system. There's a lot of ways that you can look. You can look at different threads. You can look at handles. There's all sorts of crazy stuff that you can actually watch occurring here. If you open it as administrator, you can right-click and kill processes really easily, like really awesome. You can pass specific executables to virus totals, looking for hashes of malware or whatever. So it's pretty awesome. Now that we've shown you how to not only inject into an application, we've also shown you how to see it happen with Process Explorer and Process Monitor. We're going to go ahead and wrap the video up here. If you learned something, please hit the like and subscribe buttons. It'll help to get this information out to anyone else who's looking for it. And thank you, and happy hacking.